on how it's made. Airboats. Onions. 3D metal printing. And curved cabinet doors. An airboat is a flat-bottomed vessel with a huge propeller at the back. All the boat's mechanics are above the waterline, and just a bit of the hull rests below. This makes the airboat the preferred mode of transport through shallow water, particularly marshes and swamps. To steer an airboat, large vertical rudders direct the propeller's airflow. At full speed, an airboat can hit 100 kilometers per hour. The boat's hull is made of aluminum that's about 5 millimeters thick. Workers stiffen the hull's bottom plate with aluminum T-bars positioned 18 centimeters apart. After they clamp the T-bars, a jig descends to hold everything steady as workers weld on the strips. Next, they weld on aluminum sheets to form the sides of the hull. At the front, they push the bottom upward before welding, giving the boat a curved bow. They complete the hull by welding on a sheet across the back to form the transom. To that, they weld a splash plate that prevents water from coming over the edge into the back of the boat. Next, they weld various parts to the front of the boat to reinforce it structurally and to create a covered storage area. Once that's done, they screw a thick sheet of high-resistance polymer to the bottom of the hull. Should the boat scrape against a rock, this layer will shield the hull from damage. Once that's secured, they paint the inside of the boat with a blend of epoxy and paint. This forms a layer of what they call webbing. On the outside of the boat, they apply a coat of primer, followed by 2 coats of durable marine paint. Meanwhile, others have constructed and painted the boat's above-water structure out of steel or aluminum tubes. The rigging, as this structure is called, supports the mechanics, 2 fiberglass seats, and the instrument panel. They mount a belt-driven reduction unit to the boat's gasoline engine. This unit reduces the propeller speed in conjunction with a pre-assembled set of gears. Without it, the propeller would turn at the same rate as the engine. This would exceed the propeller's operating limits and destroy it. The engine is now ready to take its place at the rear of the rigging. Heavy-duty bolts secure it. Under the engine goes a 190-liter fuel tank. At the very back, an aluminum radiator. Then they bolt the rigging to the hull's T-bars. Next comes a floor panel and a 3-passenger bench seat with a storage compartment underneath. The boat's exhaust system consists of stainless steel pipe, which attaches with band clamps to a header coming off the engine. The other end leads to a stainless steel muffler. From that, an exhaust pipe runs out the rear of the boat. Next, they mount the propeller guard, a stainless steel safety cage that surrounds the engine and propeller. The 3 propeller blades are made of carbon fiber. Aluminum rudders steer the boat by directing the propeller's airflow. Cables or rods connect the rudders to a control stick. Smaller airboats like this one are ideal for hunting and fishing. There are also much larger pleasure models that carry 18 or even more passengers on excursions. Historians believe consumption of this common vegetable dates back to prehistoric times, when it grew in the wild. Man eventually learned to cultivate onions, and this strong-tasting plant bulb became a food staple of many ancient civilizations throughout the world. In ancient Egypt, the onion was an object of worship, the inner structure of concentric rings symbolizing the eternal circle of life. Today, mechanical harvesters pull the bulbs out of the ground and lay them out in rows. After drying for a day or two, a tractor collects them into large baskets for storage. To prevent spoilage, the onions are stored at between 1 and 2 degrees Celsius. When they arrive from the field, their first stop is a cooling tunnel from which powerful fans remove the heat. The vegetables take about 5 hours to cool down to the storage temperature. The grower separates the onions according to variety and size, then either bags them for sale whole or sells them to a processing plant. At the processing plant, workers load the onions on a conveyor that leads to the peeling and cutting stations. A cutter chops off each bulb's top and tail simultaneously. It also scores the skin to prep it for peeling. The onions then move into a custom-designed peeling machine. It uses a combination of air and water pressure to blow off the skin. The onions then roll off the peeler and pass before quality control workers who swiftly cut away bruises and any other imperfections, as well as anything the cutter and peeler might have missed. The next machine rinses the onions with cold, ozonated water that kills bacteria. Then the onions pass through a metal detector, just as a precautionary measure. At this point, there's a fork in the processing road. One direction leads to slicing, the other to dicing. On the slicing line, workers load the onions into tubes that feed slicing blades. These blades are adjustable to output slices anywhere from 1.5 to 25 millimeters thick. Workers gather up the complete slices and fill 2.3 kilogram plastic trays. A conveyor moves the trays through a machine that seals them with plastic film. The film has micro-perforations designed to allow in just the right amount of oxygen to keep the onions fresh. On the dicing line, meanwhile, the onions collide head-on with a rotary blade that chops them to bits ranging from 3 to 25 millimeters in diameter. The diced onions then go for a bath in cold water. Chopping an onion releases juice from its tissue, paving the way for bacteria to grow. This cold water treatment reverses the damage, restoring shelf life. Next, an escalator transports them from a spin dryer to the packaging department. There, an automatic scale portions out the specific weight they're packaging in this production run. When the target weight is reached, a trap door swings open, dropping the portion into the waiting package. Restaurants buy their diced onions in jumbo-sized bags. The filling machine automatically forms plastic into a bag, adds a zipper closure, then seals the bag. For grocery stores, the factory packages smaller quantities of both diced and sliced onions in plastic containers. Kept in the fridge, they remain fresh for at least a couple of weeks. For busy cooks, it's a convenient, no-tears time saver. Building complex shapes out of metal typically requires weeks of manufacturing, using tailor-made casts or precise machining techniques. But 3D metal printers are faster and cheaper. They build objects from successive layers of metal powder, which are then fused together at high temperatures. "3D metal printing makes it easy to manufacture complex metal shapes using a fully automated process. Every item starts with a computer model of the object. This is the build box in which the object will be created. A technician plugs in electric heaters and pours superfine stainless steel powder into the box. The heat will keep the metal powder from clumping. He pushes the box into the machine, then fills a feed box with more stainless steel powder, which will be needed later in the process. The machine spreads the first layer of stainless steel powder in the build box. Tubes carry a binding substance to the machine's print head. This binder acts like weak glue and is ejected in very narrow jets by the print head. As the print head moves back and forth over the stainless steel powder bed, it deposits binder at the exact locations specified by the computer. As soon as the print head has finished printing a full slice of the object, powerful overhead heaters ensure the layer is completely dry. A roller applies a new layer of powder a fraction of a millimeter thick. Then the print head adds a new layer of binder. This builds the object from the bottom up. The printing process takes several hours. Once the layering is done, they put the build box in a curing oven, heated to 180 degrees Celsius for 24 hours. This will evaporate all the moisture and harden the binder. They vacuum out the loose powder and the piece emerges, its stainless steel particles lightly held together by the binder. They gently blow air to dislodge any excess powder. At this point, the object is very porous and contains about 40% air. It is so fragile that it could easily be crushed with bare hands. Using more stainless steel powder, they prepare another box in which the piece will be infused with bronze. They're making a support structure on which to rest the pieces during the next phase of the process. They carefully fill the box with alumina oxide grit, which will support the pieces during the infusion process. This dam prevents the grit from leaking out. Now, they pour in bronze powder. The piece is then heated in a furnace at 1100 degrees Celsius for 24 hours. This melts the bronze, which then gets sucked up into the piece like water by a sponge. Infused with bronze, the piece is now solid metal. They knock off the base with a hammer. It's taken just a few days to build this intricately designed piece of hardware. It can now be polished, gold-plated, or painted to match any decor. Whether they build sophisticated door handles or fancy sculptures, 3D metal printers work faster than conventional methods at just a fraction of the cost. To create classic, elegant style in a kitchen or bathroom, decorators typically use traditional materials such as wood and marble. Curved cabinets can heighten that effect, but their unique style comes at a higher price because, for the most part, these elegant doors must be custom-ordered and handmade. Most cabinet doors produced by this factory are custom-made. They typically start out as a sketch, which the factory transforms into a technical drawing. They then use that drawing to program the automated woodworking machines. After cutting all the pieces of wood they'll need, they run each one through a planer. It simultaneously smooths both the top and bottom surfaces. A cabinet door consists of a center panel surrounded by a frame. This machine, called a molder, carves the frame's two vertical pieces and cuts a groove on one edge, into which the center panel will fit. To construct that center panel, a worker feeds planks through a wood shaper that bevels their edges. The angle of the bevel is such that, when the pieces line up side by side, they'll form a curve. After trimming the pieces to the length of the center panel, another worker runs them through a glue applicator, which coats the beveled edges in adhesive. Then she lines up the pieces in an assembly fixture that's been adjusted to the center panel's width and radius. Once everything's positioned, she applies clamps, which force the pieces tightly together. The glue sets in 20 minutes. Once the glue cures to full strength, the piece goes onto a computer-guided router. It rounds both sides of the panel for a smooth, seamless look. This particular door has a concave curve. Others can have a convex curve or a crossbow curve, which is S-shaped. The same router now automatically switches to a different type of tool and profiles the panel's edges. It also carves a tongue that fits into the groove in the frame pieces. The same machine can then load another tool to engrave a custom motif or monogram if the customer desires. Next, a computer-guided sander smooths out the panel, preparing the wood for stain or paint later on. Making the frame's horizontal pieces is more complex than making the vertical ones, because the top and bottom have to curve just like the center panel. Workers coat thin slices of wood with heat-activated glue, then stack them over a curved form in a press. The press squeezes the slices tightly together. Then a high-frequency electrical current generates intense heat, triggering the adhesive. The bonded slices exit the press looking like a solid, curved piece of wood. Once the glue has set, a computer-guided router carves it to the same decorative style as the vertical pieces. It also miters the corners, so the horizontal and vertical frame pieces will fit together seamlessly. All that's left to do is glue the frame to the panel. The tongue running along the panel's perimeter fits neatly into the groove of each frame piece. Workers now clamp everything together and let the glue set for half an hour. Then the cabinet door goes off for painting or staining. This factory produces curved cabinets in 10 different types of wood and dozens of colors and finishes, opening the door to endless design possibilities. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.